This section is a polar equation of conics. In fact, this polar equation, we're going to define it using eccentricity E, and which represent the ratio between a fixed point on the conic and any point on the conic section P, and then fix the point F, one of the focus, to the distance, another fixed line, which we call it a directrix. And now ratio is between PF and the distance between PD is called the eccentricity. Now equation of the conics, polar equation of the conic is R equals dE over 1 plus minus E cosine theta, or 1 plus minus E sine theta. Now I'm going to explain this equation first with the R equal dE over 1 minus E cosine theta. So if E is greater than 1, it will be a hyperbola. If E is less than 1, greater than 0, then it's an ellipse. If E equal 1, it's a parabola. All these are conic sections, and they have a very similar equation, R equal dE 1 minus E cosine theta. Now, how do I get this polar equation? I'm going to explain that here. And so I put the fixed line directrix x equal negative d, and I draw the conic section. This may be part of a hyperbola, part of ellipse, or just a parabola. And now any point on the conic section P is represented by r theta. So r theta here is a polar coordinate of the point on the conic section. Now all of this polar equation, there's one common thing is that they all have the focus on the origin. So ellipse has two foci. So one of the focus will be origin, and the other focus will find it. And now parabola has only one focus, and so that focus will be at the origin. Hyperbola has two foci, and one of the focus will be at the origin. And all of conic section has a directrix. So this one is the directrix. Now E, the eccentricity, is the ratio between PF and DP. Now, PF is nothing but the distance between 0, 0 to r theta point. So PF is in fact just r. And now all over. Now distance between D to P is, this distance right here is D. This is D. And plus this. And which is nothing but the horizontal leg of this right triangle. That is r cosine theta. And so dP is simply d plus r cosine theta. Now, when it comes to polar equation, you must have an equation as r as a function of theta. So I'm going to solve this equation, E equals this one for r. So I'm multiplying both sides by denominator. So d times E plus r times E cosine theta equals r. My goal is to solve for r, so I'm going to subtract both sides by this. So what I have is r minus r e cosine theta is equal to dE. Now r is a common factor. If I factor it out, 1 minus e cosine theta equals to dE. So then I divide both sides by 1 minus e cosine theta, and I get the equation dE over 1 minus e cosine theta. So when you have dE over 1 minus e cosine theta, conic sections look like this. Parabola, e equal 1, or ellipse, e is less than 1, or hyperbola with one of them this one, and the other one is somewhere else, the opposite side of this one, opposite side of directrix. And so knowing that it's dE over 1 minus e cosine theta has something to do with the x-axis, and it is open to the right parabola. So it's elongated ellipse, so major axis is on x-axis, or hyperbola sideways. And so if it's a plus, then this will be shifted to the other side. So I'll go example by example. So I'm going to give you a summary before I go over examples. So I'll equal dE over 1 minus E cosine theta with the, notice the x-axis and y-axis as a black axis, and whether it's a conic section, ellipse, or hyperbola, parabola with a 1 point focus at the origin, all of this. That's 1 minus E cosine theta in the denominator. Now, if it's 1 plus E cosine theta is in the denominator with dE as a numerator, then it is opposite direction. So it's a parabola with one of the focus, parabola with the focus at 0, 0. So this one is a focus. So all of this, one of the focus is 0, 0. So 0, 0. Now in this case, directress is x equal d. So one of the focus is at 0, 0 with ellipse. Now you notice that it's elongated, so major axis is x-axis, but then it is more elongated to negative x-axis. Now hyperbola with vertex focus at the origin. So there is one focus at the origin, and one of them is open to the left and the other one is open to the right, so there's some focus on the other side. So this will be the one of the focus at the origin, the other focus will be somewhere here. And so that's dE over 1 plus E cosine theta. So they are something to do with the x-axis. Now dE over 1 minus E sine theta, it's a parabola open upward or ellipse elongated along positive y-axis, or one hyperbola goes up, the other hyperbola goes downward. So major one is on the positive, open to the positive y-axis. Now, if R equal dE over 1 plus E sine theta, it's a reflection of that. So it's a parabola open downward with the focus at here. So all of this focus is at origin, and one of the focus is at origin, if it's an ellipse, and one of the focus is origin right here. And now this one major piece of hyperbola is facing downward. So now sine, if you have 1 plus E sine theta, 1 minus E sine theta, it's elongated toward, elongated along y-axis. Now I want to do an example here. It's got a R equal number over 3 minus 2 cosine theta. Now then I compare this one with the R equal dE over 1 minus E cosine theta. To know what E is, I need to make this number 3 as a 1. So I'm going to divide, just to know what E is, I'm going to divide each ones by 3. So 15 divided by 3 over 3 divided by 3 and 2 divided by 3 and a cosine theta, which implies E is 2/3. So E is the number in front of cosine theta, 2/3, and that's less than 1 and greater than 0. So that means this conic section is an ellipse, and it's a 1 minus E cosine theta shape, so it's an ellipse open to the elongated along x-axis and longer toward the positive x-axis, like this one, the one in the middle. So one of the focus will be at the 0, 0, directress on the negative x-axis, and it's elongated along x-axis, but more to the positive x-axis. That's an ellipse. So we are looking at this ellipse. Now we are going to look for equation like this. Since major axis is on x-axis, so what we need is vertices and the point of major axis. So imagine you're looking for this point right here, and you're looking for this point right here. So these are positive x-axis or negative x-axis point. So I need a 2 point, which is a vertices, the end point of the major axis. So I'm going to make a little table with r theta point. Since the positive x-axis is a theta equals r, theta equals 0. So I'm going to write theta value. And so we are looking for point at x-axis. So I'm going to substitute theta by 0 radian. And I'm going to substitute theta by pi radian, because both points are either positive x-axis or negative x-axis. Now then, what will be the corresponding R value using this equation right here, using this equation? So I'm substituting theta by 0 into that equation. So R is equal to 15 divided by 3 minus 2 cosine 0. Cosine 0 is 1. And so it's 15 divided by 3 minus 2 times 1. 3 minus 2 is 1, so we talk about R equal 15. And so if I convert this R theta point to right away xy point, knowing that it is on positive x-axis with the distance 15 from 0, 0, you can imagine it's simply 15, 0, even xy coordinate. So this point right here is simply 15, 0 as an x and y coordinate. Now if I substitute theta by pi into that equation right here, and cosine pi is a negative 1. So it's a 15 divided by 3 minus 2 times negative 1. So that makes it 3 plus 2. So 15 divided by 5, which is R equals 3. So you're going to look at that. When theta equals pi, 15 divided by 3 minus 2 cosine pi. And cosine pi is negative 1. So what you're getting is 3 minus 2 times negative 1, which is 15 divided by 3 plus 2, 5. And that's R equals 3. And now that's R theta point. So if I convert this to right away, R theta point, this is a rectangular polar coordinate 3 and pi, but obviously that's on the next negative x-axis with the distance 3. You can imagine distance from 0, 0 is 3. Since it's on negative x-axis, distance 3, so the point in rectangular point should be negative 0, 0. So when in doubt, you can say x equals 3 cosine pi, which is negative 3. Y equals 3 sine pi, which is 0. You get the same point, but it's automatically implied this rectangular coordinate right here is a negative 3, 0. And that's serving as a vertex, vertices of ellipse. Vertices are end point of major axis of ellipse. So then what is the center? And so these are vertex of vertices of an ellipse, meaning end point of major axis. Now center is nothing but the midpoint between the two vertices. So how do you find the midpoint between two points? These 2 points, you add 2 coordinates and divide by 2. Of course, 0 divided by 2 is 0. And so that's 12 divided by 2. So the midpoint is simply 6, 0. And that's going to serve as an HK in the equation of ellipse. Now, so center is 6, 0 right here. Center is HK 6, 0. Now, one thing you need to notice that there is a focus at origin. That means distance from center to the focus is C. And distance from center to the one vertex is A. And so, and distance from center to the vertex is A, is that means 9, 6 minus negative 3. And C is simply 6 over here. So now, when it comes to ellipse, it's elongated sideways, so A is bigger than B. A square minus B square has to be C square. Now A is 9, so 81 minus B square and C square, I just got that, 36, 6 to the square, which implies B square is simply 81 minus 36, which is 45, which means B is equal to plus minus square root of 45. And that's 9 times 5, so it's plus minus 3 square root of 5, that's B. We are not going to get the endpoint of minor axis, and so I'm just going to get a rectangular equation of this ellipse. Equation of ellipse is x minus h, 6 to the square, over a squared. A is 9, so a squared 81, plus y minus k squared, k is 0, over b squared, which is 45, and equals 1. And so this is going to be an equation of an ellipse, rectangular equation of the ellipse. If you want to find the second focus, and since the distance from center to the second focus has to be 6, and so this one will be 6 plus 6, 12, 0 will be your second focus. So then focus, meaning foci, will be 0, 0, and 12, 12, 0. And vertex, we already got that, 15, 0 and negative 3, 0. And center is 6, 0. And equation of this ellipse over here, x minus 6 to the square over 81 plus y squared over 45 equals 1. If you want to look for the directress, DE is equal to this number 5, and DE equals 5. And we know that E is 2/3. And so D is equal to 5 times 3 over 2. So you can see that D is equal to 15 over 2. So the equation of directress should be x is equal to negative 15 over 2 as a directress. Now we want to look at next example. It's got 32, R equals 32 over 3 minus 5 sine theta, which is similar to R equals dE over 1 minus E sine theta. Now if you recall, it is one of these. So if E is greater than 1, it's hyperbola, and one of the hyperbola is open to upward. Now I need to know what E is, so that means I need to make this number 1. So I'm going to divide each of them by 3. So R is equal to 32 divided by 3, 3 divided by 3, which is 1, 5 divided by 3, and sine theta. So which means 5/3 is your E, and 5/3 is bigger than 1. So this equation as a conic section is means hyperbola. It is hyperbola. One open upward, the other one open downward. The one focus at 0, 0. Now I need to find the vertex and the point of the transverse axis. Now vertex is sitting on y-axis. Now y-axis is angle theta has to be either pi over 2 or 3 pi over 2. So I need to find the vertex, I need r theta. But since the vertex is sitting on either positive, both are sitting on negative x-axis and negative y-axis, but y-axis is either angle pi over 2 or 3 pi over 2 because it's y-axis. Now I'm going to substitute these angles to this equation given over here. And so sine pi over 2 is 1. So if theta equal pi over 2, it will be 5 times 1, and 32 divided by 3 minus 5, because sine pi over 2 is 1. So 32 divided by negative 2, which is negative 16. Now this is r theta coordinate. Now if you know that it is a pi over 2, so angle is pi over 2, but r is a negative, which means it's not on positive y-axis, it's on negative y-axis with the distance 16 from the pole. So you can imagine xy coordinate must be simply 0, negative 16 as a vertex. So these are vertices and the point of a transverse axis of a hyperbola. Now another one is when angle equals 3 pi over 2, because we are talking about point on the y-axis. So if I substitute theta by 3 pi over 2, sine 3 pi over 2 is negative 1. So it will be 3 minus 5 times negative 1, so 3 plus 5. So it's a 32 divided by 8, and which will be 4. 32 divided by 8 is 4. And so we are talking about angle 3 pi over 2 is negative y-axis with the distance 4 from 0, 0, which means as an x and y coordinate, rectangular coordinate, since it's obviously sitting on negative x-axis, negative y-axis with the distance 4, it should be 0, negative 4 as a rectangular coordinate. So this point is converted to rectangular point right away, 0, negative 16. And this point is converted to rectangular coordinate right away as a 0, negative 4, which means that this vertex is 0, negative 4, and this vertex is 0, negative 16. And now, of course, center is a midpoint between these two vertices. Center HK is a midpoint of these two vertices. So that means 0 plus 0 divided by 2 is 0. Negative 16 plus negative 4, which is negative 20, and divided by 2 as a midpoint. Midpoint is a 2 coordinate addition divided by 2. So center is 0, negative 10, and this is your HK. And that's a center. So center is somewhere here, 0, negative 10. And now center to the vertex is B. Center to the vertex is B. And center to the focus is C. And so there is another focus over here somewhere, same distance. So that means that C is simply 10, because center is 0, negative 10. Center is 0, negative 10. And 0, negative 10 to the focus 0, 0 is 10, which is C is 10. Now center to the vertex, one of the vertex, whether it's a negative 10 to negative 4 or negative 10 to negative 16, B is the distance from center to the vertex, and which is simply 6. B is 6. Now when it comes to hyperbola, A squared plus B squared equals to C squared. And so I know C squared 10 to the square 100, and A squared is not given, but since B squared is given, B is 6 and 6 to the square 36, I can say A squared is 100 minus 36. A squared is 64, so that means A is plus minus 8. So now let's look at the equation of hyperbola. When it comes to equation of hyperbola, and now it's open to the up and down hyperbola, so you would have a negative sign in front of y and in front of x. So you would have y minus k square over b square, which is 36, minus x minus h square, h is 0, over a square is 64, equals 1. That's the equation of the hyperbola. Now when it comes to hyperbola equation, you need one more thing, which is asymptote. Now asymptote is y plus 10 plus minus b over a, and b is 6, a is plus minus 8. So it's 8, b over a, and x minus h, which is 0. Of course, you don't leave 6 over 8 as it is. You're going to simplify, divided by 2, divided by 2. So your asymptote equation is simply y is equal to plus minus 3 over 4 x minus 10. That's the equation of asymptote. Now I added two asymptote into my graph, so this must be going upward. So negative 3 over 4x plus 3 over 4 minus 10. And this one is going downward, so it's a negative 3 over 4x minus 10. So two asymptote to the hyperbola as well. And so for this one, What's important is the rectangular equation and finding the asymptotes equation as well. I forgot one thing is directress, and so this number 32 dE equals to 32 divided by 3, the numerator, 32 divided by 3. And we know that E is a 5/3, so I substitute by 5/3. And so I can cancel multiply by 3 both sides. And then I know that D is equal to 32 divided by 5. D is equal to 32 divided by 5. But D is, this line right here, is on the y-axis, negative y-axis. So this one, the equation of directress will be y equals to negative 32 over 5 is the directress. Now I want to do one example of parabola. That one is obviously it's already in that form, so E is equal to 1. And so that's implying this one is a parabola. Now parabola with the DE equals to 2, that means the E equal 1, D equals 2 right here. And this one is a parabola open downward. So because it's 1 plus E sine theta. So it is this one. Now D is 2, so I don't have to compute complicated computation here. So the y equal 2 is obviously the directress. Now focus is on 0, 0, so the vertex point right here. And since it's on y-axis, so I'm going to get 1 point, and theta may be pi over 2 or 3 pi over 2. And when theta equals pi over 2, sine pi over 2 is 1. So it's a 2 over 1 plus 1, 2 divided by 2, which is 1 right here. And this r theta point is going to be vertex of the parabola. So this is a vertex, so I can automatically convert this to xy coordinate, rectangular coordinate. Since it's on y-axis, x coordinate must be 0. Now distance from the pole, the 0, 0 to the vertex is 1, r value 1. So that point is 0, 1. That means this vertex is simply 0, 1 right here. Now when theta equals 3 pi over 2, r is undefined because sine 3 pi over 2 is negative 1. 2 divided by 0, that's undefined. That's why there's nothing on the negative y-axis. So we have this parabola open downward right here with vertex at 0, 1. Now, since the focus at 0, 0, what that implies is P is equal to simply 1. So distance between vertex to the focus is P. Now, this is definitely x is squared. So the equation of this parabola is x minus h to the square equals to 4p. P has to be negative because your point open downward. And so I should say negative 1 here. And x, y minus k. Now this is your vertex is your hk. Now h equals 0, so I have x squared equals to 4p. P is negative 1 because it's open downward. P is vertex is a 0, 1 and focus is a 0, 0. So distance from vertex to focus is a 1, but since it's open downward, the p has to be negative. So it's a negative 4 y minus k and y minus 1. K is 1. And so this is the equation of this parabola with the directress at y equal 2. Now, you're welcome to rewrite this with more conventional notation. So x squared equals to negative 4y plus 4. And then you can swap these two. So 4y is equal to negative x squared plus 4, and you divide by 4, y equals negative 1 over 4 x squared plus 1. And that will be a more conventional y as a function of x, but this will be just fine as a rectangular equation. And when it comes to parabola, that's all you need. Now remember that 4p is the length of a focal diameter. And now you notice that this focus is sitting on 0, 0. So this endpoint right here on x-axis, from distance, this will be endpoint of lattice rectum, and total distance is 4. So that got to be 2, 0. And it got to be negative 2, 0. You can also confirm that by substituting theta by 0 and pi, and you will see that r is 2 or negative 2. And so this ends the section. Hopefully you can view this and do more example at the homework.